when you upload, we hit all this first conversation, and then we start with this. Okay? Yeah. So welcome to all to this fifth day of the lecture series by Gyan, by Professor Sophie, and we are now in day 5. And it will continue, and I sent a mail to Gyan because there was a little more mistakes, like tomorrow and day after tomorrow, there were no lectures, but we will continue in the revised schedule. That means we are not going to rest like in Genesis after 6 days, like God. So we have to continue with the complexity, and because it becomes more and more complex. And I'm so happy that you're all present and showing your continuing interest and enthusiasm in this lecture, and also for Sophie for engaging you all in the discourse of a complex world. Yeah. Okay, now the fifth day of the emergence and understanding of complex.
Thank you so lot, Babu, and welcome all once again. And we are in the mid of our lectures, and we meet the core of our work on understanding of complexity and complex world. For this day, we will encounter what one can name essential feature of complex phenomena. You can also remark, after what we said yesterday, that there are sort of contradiction of unclarity about this expression, because we are talking about phenomena, okay? So to postulate an essence of phenomena is already some way problematic. So please take essential feature of complex phenomena, not in an ontological, firstly, but in epistemical way. So there are features by which phenomena are taken or are understood as complex, or as something complex can be designed and taken as such. So we have nothing to do with the ousia with the substance we mentioned in the previous day, in particular yesterday in our ontological discussion, nor with the singular essential feature of phenomena taken in account by modern science. And there is the first asperity for us, because we must talk in plural with the sum of oscillatory degrees of freedom. It means not that such degrees of freedom are uncertain, but for our forma mentis, for our state of mind, or for our education, essence is fast unconsciously related to the unique feature. Okay? Now we have to do with essential feature of complex phenomena, not things, and then we move in an epistemological and scientific horizon, and not yet in an ontological one. Because, as said yesterday, our ontological horizon, given the plurality of phenomena, and in complex phenomena, the plurality of hierarchical level, organizational level, implies to get a meta-ontological perspective. Okay? So just as premise. The title that was presented already in the first lecture, what does it mean to look at such epistemic feature of complex phenomena or complex system, and we will approach that capping very soon in the next slide from the philosophical point of view of concept analysis. The multiplicity of such features which entail epistemic properties is to be brought to a synoptical consideration and not a synthetical one. One is the difficulty is that we cannot make an architecture of such feature in order to design an essence as such to project on every complex phenomenon. So we have not a stable, definitive, and complete list of properties that we can attribute to every single complex phenomenon. That is what changed from metaphysics, and I will say what pose many problems to metaphysics. Okay, not by chance we speak today, even in analytical context, of meta-metaphysics or meta-ontology. Okay, there is not sort of personal choice; it's sort of necessity given by the thing. So synopsis is not, or not yet, in relation to our last question yesterday, a synthesis. Thus, one could simply list properties and concept of the complex, non-steady interaction, symmetry breaking, holonomic or non-holonomic limitation, intrinsic global coherence, modularity, path dependence, model specificity or model plurality, what we will approach tomorrow, as well irreversibility or historicity, amplification and sensitivity to initial condition, what we will approach also tomorrow by linking our analysis to the butterfly effect, what we have seen yesterday also, or even coordinated spatio-temporal and functional organization differentiation. There's many, and that is important for our ontological approach, many metrics on which a complex phenomenon manifests itself. In the fifth lecture, we will outline a general but epistemic informed overview of complex phenomena from the point of view of systemic interaction of their feature. For this reason, we talk about complexity in terms of complex systems. There is an intentional choice. So complexity is not sort of holistic, diffuse properties of phenomena. We have not to take the thing holistically, even if statistically many phenomena, even almost all phenomena in the world can appear complex. But we have not alleged to make the jump to the local, from the local to the global. So we don't talk as complexity as an ontological property of the world, but we talk of complexity in relation to complex system. Okay? That's allow us to spare the risk or avoid the risk of such holistic superstition coming from the enthusiasm of discovery as complexity science. Everything is complex, the world is complex. We can talk about the complexity of the world in two different ways, of course. We have also talked, at the first day about the word complexity, but just as an introductory key feature. Then we differentiate and we link complexity to a system. So complexity is the property of a system. So we have a sort of meta-theoretical reduction or association of our questioning of complexity or about complexity to the notion of systems. Complexity is firstly approached as the property or set of properties of a system. Complex systems are everywhere. You can find it in Sandra Mitchell's introductory book on simple truths. Living cell and microorganism, economy and global supply chain, as we were saying yesterday, communication or transportation systems, cities, societies, migration, ecosystem, and so on. And that book is on the drive. So in order to step or to smell what it is, it's better to begin after the course, if you will, if you are interested to go further with this book. Then there are other books on the drive, and we will speak about them after. Another book that you can find, just another nature of think, you can find in the drive is the Philosophy of Complex System on the Encyclopedia for Philosophy of Science of Elsevier. Is a wonderful thing. There's 700 pages with 2 introductions. That is very, very analytic. And this is the most important tool that you have to consider, okay? Just the introduction is hard enough for you for one course, okay? But the statement is very clear. The impact of complex systems on science is a recent, ongoing, and deep revolution, but a few honorable exceptions, it has largely been ignored by scientists and philosophers alike as an object of a rejective study. These quotes come from 2011, since we have a sort of explosion of philosophical issues on complexity, as well from the point of view of philosophy of science. Better said, philosophy of science is taken as a branch of theoretical philosophy, but also from the point of view, as we will see after in our ontological lectures, from the point of view of ontology, because one of the most challenging problems for contemporary ontology today, emergence, is a property of complex phenomena. And then you have 2 other books, okay? One, Philosophy of Complex Systems, is on the drive. You can also use as you will. The other I cannot find, so not the time to find, but anyway, I don't think this is on Libgen. There is this book, What is a Complex Systems? A complex system. From James Lediman, there is a very, very well-known and renowned philosopher of science and ontologies taking stands for a nontic structural realism. And from Caroline Wisner, she's a physicist. Okay. Then you have another book, is on the drive. Complexity, a guided tour for not Sandra Mitchell, but Melanie Mitchell. They are not parents. And such a book coming from someone that belongs and teaches in the renowned Santa Fe Institute. This is sort of the Vatican of, not Orthodox, Vatican of complexity science, okay? It's harder as the first, okay? But you can use as you will. So we will just concentrate ourselves on sparse quotes and consideration maybe in the workshop of this book, in particular the 5th chapter, okay? And today and tomorrow on the introduction of two philosophy of complex system encyclopedia and book. Unfortunately, we have just 10 lectures, but let me say that the introduction is very, very worthy to change our view in order to understand complexity as a key feature of our world, okay? Even via negativa, as I can say, even negatively, that is by matching what you don't arrive to understand. What are the blind spots of your understanding? You know? That is, you have a certain approach to knowledge, you have a certain approach, even my close friends, to ontology, to theory of knowledge, and so on and so on. When they try, I said yesterday, to read with the fiction to having to clarify to another students, okay? Just the introduction, they stop. Not because they are not intelligent enough, or not because they are not philosophers of science, okay? Because there is a sort of feature of our mind approaching the world that is not matching with the challenge posed with that. So you can also have very, very refined notions in ontology, in history of philosophy, or even in philosophy of science. So you're a very renowned scholar in these fields, competent. But when you meet such introduction, you are like sort of Alice in Wonderland journey, okay? Not because it's a wonderland, it's a sort of intertwining of problems, but it's also challenging for our idea itself of rationality, okay? So now let's consider the second tutorial. Why? Because we will consider together the tutorial after in our workshops. Maybe not today, after our epistemical part of the journey, we will consider both together, okay?
Theory by looking at the major theoretical frameworks that are considered.
So, I have to no? Okay, that's it. So, yesterday we noticed how much new elements intertwined occur, or that do occur in a simple, short, well-made, very well-made tutorial, what is a complex system, okay? Now you can notice that meta-theoretically. That is, there are complex systems in the feature of properties that we noticed yesterday. Meta-theoretically, it's translate itself in complexity science, I would say, or complexity theory. I would say complexity theory as an horizon of complexity sciences. So people that, of course, we name it, to make it simply, we name it complexity theory or simply complexity science. There is just a huge step between both, because a theory presupposes a sort of coherent architectonical unification. But anyway, the real, really we have to talk about complexity sciences, and the challenge of a philosophy and understanding of a complex world is to define or to sketch the horizon of a possible theory. Okay? So complexity theory is not an already gained dimension. Is as the horizon of our research.
To form part of it and contribute to the study of complex systems.
This is just an overview.
In this video, we will be giving an overview to the area of complexity
frameworks that are considered to form part of it and contribute to the study of complex systems. Complexity theory is a set of theoretical frameworks used for modeling and analyzing complex systems within a variety of domains. Complexity has proven to be a fundamental feature of our universe that is not amenable to our traditional methods of modern science. And thus, as researchers have encountered it within many different areas from computer science to ecology to engineering, they have had to develop new sets of models and methods for approaching it. Out of these different frameworks has emerged a core set of commonalities that over the past few decades has come to be recognized as a generic framework for studying complex systems in the abstract. Complexity theory encompasses a very broad and very diverse set of models and methods. As
generic framework, philosophically speaking, is not yet a theory, okay? It's a general framework because and for this reason we have to deal, we cannot deal, we will just mention meta-theoretical approach in order to understand the intertwining ontologies inhabiting a complex systems. But from this point is to have sufficient strong languages in order to build a meta theory and to have a complexity theory from the sparse and manifold of theories and sciences is just another word, what they say.
As yet, there is no proper formulation to structure and give definition to this framework. Thus, we will present it as a composite of our four main areas that encompass the different major perspectives on complex systems and how to best interpret them, including self-organization theory, nonlinear systems, network theory, and adaptive systems theory.
So now you have, is a very, very simplifying. We have not those four families of theories, but you can also notice to what our previous lectures were oriented to, because now we can understand vaguely why we study nonlinear system and why nonlinear system theories are deeply linked with the revolution of complexity, because the science of the modern science is linked to linearity. Self-organization, of course, because the autopoiesis and transfer and stock of information by feedbacks is an essential feature, as said yesterday, of a complex system as a living cell. Adaptive system, because we mentioned, okay, yesterday, the idea of an open systems. So if you copy the idea of an open system exchanging information with the environment, you can think to this system also as a self-adapting or adaptive system. And the network theory, because at the end of our lecture yesterday, we watched the heterogeneity of elements isolated by taxonomy as nodes, and the links and the relationship between those elements must be studied by a sort of general network of, general framework of network theory.
Firstly, self-organization and emergence. Complex systems are composed of many small parts without centralized control, examples being flocks of birds, financial markets, social networks, global logistics networks, or the human brain. Without centralized control, global organization is an emergent feature of the local interactions between the parts. Whereas the term emergence is a general concept referring to how new levels of organization are formed as we put component parts together, the theory of self-organization presents a number of concrete models for understanding how this process takes place. The model of self-organization draws upon information theory to understand organization in terms of information and entropy. It draws upon ideas in physics surrounding synchronization and pattern formation, and ideas in chemistry surrounding dissipative systems and far from equilibrium processes. Here we are looking at how elements governed by simple rules synchronize their behavior with the result being a process of self-organization as patterns of organization emerge from the bottom up. Researchers try to model complex systems by capturing these local rules and using computational tools like agent-based modeling to try and simulate the process through which order emerges out of initially homogeneous or disordered states. Next, nonlinear systems and chaos theory. Nonlinearity is an inherent feature and major theme that crosses all areas of complex systems. A lot of nonlinear systems theory has its origins in quite dense and obscure mathematics and physics. Out of the study of certain types of equations, weather patterns, fluid dynamics, and particular chemical reactions has emerged some very counterintuitive phenomena in the form of the butterfly effect and chaos. Chaos theory, which is the study of nonlinear dynamical systems, was one of the first major challenges to the Newtonian paradigm that was accepted into the mainstream body.
The Newtonian paradigm, the most challenge is, of course, the three-body problem. Okay, we mentioned it before. Okay, so for the Newtonian paradigm, let's program. Okay, if we put a third body M3 and try to agency the equations, problems arise. For this reason, we have the tree. We have the man sitting, we have the apple, okay? And then we have another thing, that is the butterfly.
Body of scientific knowledge. Our modern scientific framework is based upon linear systems theory, and this places significant constraints upon it. Linear systems theory is dependent upon the concept of a system having an equilibrium. Although linear systems theory often works as an approximation, the fact is that many of the phenomena we are interested in describing are nonlinear. Processes of change, such as regime shifts within ecosystems and society, happen far from equilibrium. They are governed by the dynamics of feedback loops and not linear equations. Trying to model complex systems by using traditional linear systems theory is like trying to put a screw into a piece of wood with a hammer. We are simply using the wrong tool because it is the only one we have. Thus, the areas of nonlinear systems and their dynamics is another.
So just come back. Maybe you can orient the camera on the screen instead to. So there is sort of thinking missing here. There is linear thinking and complex system. Okay, linear thinking is, we think, if you will, deductively or analytically linear. Okay, there is not the challenge to the Newton paradigm or to the Newton program, but it's the challenge to Cartesian program. Okay, because the Descartes idea of chaîne de raison, the order of argumentation, must be linear. So the problem is that we have not to change the linearity as such, because our argumentation is progressive and our deductive chain are linear, but it's not one-dimensional. That's the problem. It's not because we have to stop to think linear. It's sort of philosophical oxymoron, okay? We have to implement the linearity in many dimensions and be able synoptical to grasp together this multidimensionality of the linearity of our reasonment, okay? Because don't think linearly because means for us think fuzzy is not the solution, okay? We think linearly, but multidimensional, because we have multiple ontologies on which we have to replace the elements of our order in order to say. So in order to have a step 1, a step 2, a step 3, just in one dimension, we have to identify many steps corresponding together going in other dimensions that correspond to our regional ontological argumentation or approaches. That is the vertigo I mentioned yesterday. If you will take it seriously. Because just a philosophical, because there is a tutorial for scientists or for initiation to complexity science, but there is no explore unfolded philosophically, okay? You have to ask, for example, people say, think multidimensional, okay? Okay, it's a good suggestion, but how I have to describe a pattern in order to think multidimensional? We don't have such pattern, and I can assure you, in order to become such pattern, you have to spend years on first philosophy, if you reach, okay? Is a good suggestion, okay? Think different, think multidimensionally, or even think interdisciplinarily. But between the suggestion, the wishful thinking, and to behave a concrete framework in order to link this dimension, these inter of disciplines, or these multiple, manifold linearities, is just another stuff of task.
The wrong tool because it is the only one we have. Thus, the areas of nonlinear systems and their dynamics is another major part of the framework of complexity theory that has come largely from physics, mathematics, and the study of far from equilibrium processes in chemistry. Next, network theory. Network theory is another major area to complexity theory, as almost all complex systems can be understood and modeled effectively as networks. Network theory is a formal mathematical language, but it has proven a very practical tool for analysis and thus has found widespread application in many areas. The study of networks is probably the youngest and most active area of complexity science, again driven by the rise of computation and the fundamental role that networks are starting to play in our world with the advent of information technology. With the theory of networks and the availability of new sources of data, we are starting to get a real picture to what some of these complex systems that make up our world actually look like.
That is a more familiar picture, okay? But philosophically, you have to know how to apply to the phenomenality of the world itself. It's not just a way of representation among others. It emerges as network science, okay, or science of science, okay, in order to quote Albert Laszlo Barabasi. This is a Romanian scholar working on MIT on network theory, or Ginestra Bianconi in London, or Santo Fortunato, because we need such grammatical overstepping, okay, meta-theoretical.
We can start to see the connections within financial systems through which contagion spreads, the real-time movement of freight around the globe, or socio-political networks that influence our lives. This is a new kind of science, driven less by models and equations, but more by real-time, dense data sets. This means we are no longer left staring at models, but now have accessible visualizations to give us a much more rich, intuitive, and in many ways, real sense for what exactly these complex systems are like.
For example, in order to recover a concrete example, Albert Laszlo Barabasi applied the modelization of airport and flight circulation to the pandemics with some radical changing, and then give us an access to spread of pandemics with with central nodes, with clustering, and so on and so on. It's not just a merely theoretical speculation, okay? By handling by equation built or formulated the behavior of networks, you can also transpose or translate the behavior to other phenomena that are also complex, like the spread of a pandemic, and have a general anticipational pattern in order to solve the problem.
The main contributions to this area have come from the area of mathematics called graph theory, and again, computer science. The last major area to complexity theory that we will discuss is that of complex adaptive systems.
For example, if you read a paper I can even upload on the drive, already in the 90s, a scholar named Sherry Marcos published a very pioneeristic paper named Markets at CAS. This is Markets at Complex Adaptive System, that opened many branches of a non-classical or neoclassical approach to global economy.
Complex adaptive systems are classical examples of complex systems, and people often use the two words somewhat interchangeably. They consist of many parts acting and reacting to each other's behavior, like a school of fish swimming together, nation-states within the international political environment, or businesses in a market. They are highly dynamic and develop through an evolutionary-like process. The central issue is that of the process of adaptation and evolution. The idea of adaptation formed a central part of cybernetics that contributed ideas surrounding control systems and how systems regulate themselves and their environment in order to maintain homeostasis.
And in order to come back to yesterday, we cannot understand the key feature of cybernetics when we stay at the idea of modern science by which just quantity of matter and energy can be transferred. So the switch that we, the third switch that we noticed and discussed yesterday is essential first and foremost for biology, but of every complex system that is a complex adaptive system, living in brackets, living by transfer of information, okay? So there are theories, cosmological theories linked to the idea of holographic universe formulated in the past years that say that even information is a quantity of matter, but it is very, very abstract and we cannot contextualize it. But for the moment, information is another kind of matter of transfer. And to switch between the transfer of energy and transfer of information is essential to understand the world and not just our mind. Because since 20th century, our mind is par excellence the exchanger of information, okay? Even if the notion of information is not so clear. But now we know that even biological systems and other complex systems are ruled by cybernetically by exchanging information and stocking exchange of information.
A key issue here is that of the dynamics surrounding cooperation and competition that form as adaptive agents interact and try to pursue their goals collectively. One could also include game theory here, a branch of mathematics for modeling the interaction between adaptive agents of all kinds and the dynamics of cooperation and competition that form out of this. When the idea of adaptation is generalized to a whole population of agents and takes place over a series of life cycles, it can be termed evolution. And the theory of evolution is one of the major contributions that ecology has made to complexity theory. We now have a number of different models for understanding evolution, including evolutionary game theory, replicator equations, fitness landscapes, and genetic algorithms, among others. This is an area that has grown out of cybernetics, computer science, economics, and ecology. Lastly, we'll discuss a little of the context and significance of the area of complexity theory as it plays a somewhat unique role within the framework of contemporary science. The website Scholarpedia describes complexity theory as an emerging post-Newtonian paradigm. There is a lot packed into this short statement, so let's try and unravel and make sense of it. The Newtonian framework is based on linear systems theory.
As we will see, and you can notice this usefulness of the first two sections, of two lectures, is Newtonian paradigm has not emerged from the head of Isaac Newton. It's a process during almost 3 centuries on strong and even stronger presupposition. So if we talk, I don't like to overestimate the notion of paradigm. Of course, we all like and venerate the book of Thomas Kuhn, The Structure of Scientific Revolutions, but now is often used in a non-pertinent way. But anyway, if we have to do with a take it philosophically, if you have to do with a post-Newtonian paradigm, okay, you have to do with the emergence of new challenge for rationality. It's not just something belonging to philosophy of science, what it repeats once and once more. It's the task of rationality that changes with the emergence of this new post-Newtonian paradigm, while maintaining, as you can notice here, and we will notice in the following of our lectures, this very rigorous adherence to concept, argumentation, patterns, and so on and so on. So please don't mix the post-Newtonian paradigm or complexity science with the postmodern or postmodern philosophy. It's not say that in any way they are linked together as phenomena, as macro-intellectual phenomena of our world, okay? But there is not synonymous. They are not synonymous, okay? Because in one way, postmodern, we have a sort of radical rejection in whole of rationality of modern time. In this post-Newtonian paradigm and from philosophical texts emerging from this from this post-Newtonian paradigm, we don't discard a project of rationality, okay? We redefine from inside the horizon of our projects of rationality. It's another thing, okay?
This has been a powerful tool for helping us understand the world. Through the contributions of millions of researchers over the course of centuries, we have built up a large and sophisticated body of scientific knowledge, which is one of humanity's greatest achievements. Throughout the 20th century, though, the Newtonian paradigm and linear systems theory have become increasingly called into question as general relativity and then chaos theory proved some of its most basic assumptions to be, in fact, flawed. The fact is that much of the phenomena that we are really interested in are inherently nonlinear, such as almost all socio-political, ecological, and economic phenomena. A core challenge of 21st century science, then, is to extend this framework into the world of nonlinear systems and complexity, and this means going beyond the Newtonian framework. As Scholarpedia puts it, developing a post-Newtonian paradigm, and this is exactly what complexity
is. So, just pay attention to this, because that will, before become stronger and stronger theoretically, we will give us a very, very illustrative example of what is complexity. What is the difficulty of understanding complexity and encompassing, from the point of view of first philosophy, all these branches of knowledge, all this field of knowledge that we need to use or to consider at least in order to let change our worldview.
Theory is doing. To summarize, we have been giving a quick overview to the area of complexity theory, which we defined as a set of theoretical frameworks used for modeling complex systems within a variety of domains. We looked at 4 of the major modeling frameworks that fall under its canopy. We firstly talked about self-organization and how it gives us the tools to understand the process of emergence where global patterns form out of only local interactions. We talked about the theory of nonlinear systems and how it has emerged out of the study of chaotic physical and chemical processes. We then discussed network theory as another major domain that understands complex systems in terms of connectivity and how things flow through these systems. The last major area we looked at was the theory of adaptive systems that tries to understand complex adaptive systems in terms of the interaction between adaptive agents, cooperation and competition, and the dynamics of evolution. Finally, we tried to provide some insight into the significance and context of complexity theory as a so-called post-Newtonian paradigm as it tries to extend our scientific body of knowledge into the world of nonlinear systems.
So, for this tutorial, the goal was not too minimal, but for us it's once more difficult because it's to extend our idea of rationality. If you pay attention to what we said yesterday and before yesterday about analytical solution of equation, we noticed that Poincaré, just by putting an M3 body in the equation, find a huge problem to solve and maybe impossible to solve, just by approximation. So we have a more illustrative example of the thing. And then just in order to take it a bit lightly, and then we switch to the stronger part of the lecture. Take a pendulum, okay? If you will, from the point of view not only of history of science, but also of history of philosophy, the history of the pendulum is determining, the problem of the pendulum is determining and orienting the whole history of modern science and philosophy. Because Galilei began to pose the problem of the isochronism of pendulum oscillation, okay? And then many things come from, but let's ask just if you apply a pendulum to another pendulum, okay? Normally, you have to be able, or you must be able to use the same equation in order to have the same results. It's not the case. I don't find the thing.
A 1% difference in initial conditions quickly reveals the
This is just
chaos
a double
inherent in a double pendulum. Although this means that a double pendulum can be unpredictable, its motion is nevertheless still entirely deterministic. A 1% difference in initial conditions quickly reveals the chaos inherent in a double pendulum. Although this means that a double pendulum can be unpredictable, its motion is nevertheless still entirely deterministic.
What we announced with deterministic chaos, if you will, just by applying another pendulum to a pendulum for which you have exact equations, you have model, you have a theory of knowledge, you have everything, you become this trajectory. There is a trajectory sensitive to initial conditions, okay? There is something deterministically chaotic. Now I have to switch to presentation, but I don't know how to do. Where? F5. No. Slideshow, where is slideshow? Can you come? Okay. Presentation. Okay. Yeah. Oh, we will. So let's summing up, and then let's switch to the features of complex systems in order to ask ontological and meta-theoretical questions in the following lectures. Complexity is the global property of a numerous set of elements. We have mereology here, domain. In dynamical, often disordered, non-linear interaction that emerge in relation to the many parts of the system itself, interacting by feedbacks with its own environment. It's just a fairly summing up definition. And then you can find in the introduction of complex to philosophy of complex systems just a listing of nodes or epistemic ontological properties of complexity as property of a complex system. We have already repeated it, nonlinear interactions, irreversibility, constraints, that is holonomic and non-holonomic, that is constraints that are related to the whole, they are holonomic, or not related to the whole, related just to an organizational level, that is or to parts of this organizational level, that is non-holonomic, equilibria and stability, many equilibria and stabilities, amplification, that is sensitivity to initial condition that we watched just before with the pendulum, that is 1% of difference of initial condition, alterated entirely in a way chaotic, deterministically, the behavior of a simple, if you will, mechanism as double pendulum. Finite deterministic unpredictability. Why finite? Because people say, why when we with computer proceed with infinite or with infinitistic methods, there was also a proposed solution to Gödel problems. We can solve the problem, but we have many problems with the infinite, even with computer. Okay, symmetry breaking, that is bifurcation, self-organization emergence, intrinsically global coherence of the system because the system remains the same while presenting such emergence features. Modularity, that is hierarchy between level or even of parts that are non-holonomic constraint, multi-scale and multi-order functional organization. And if you will, the multi-scale is more difficult as the multifunctional to understand, okay? Because we have just a general idea of multitasking in our life, but the multi-scale is difficult to conceive how something, and we are deep into the ontological or meta-ontological problem, something can be individuated not by different metrics. So I choose one, I choose two, choose three metrics, and then I can catch the phenomenon with better or lesser granularity. The multi-scale are to take in account together. That is, we have different metrics that what ontologically pose a problem, and we let us to switch from ontology to meta-ontology. Autonomy, adaptation, adaptiveness, learning by exchange of information, cybernetical exchange, model specificity and model plurality, and condition-dependent laws. That is the first way. What? Condition-dependent laws. Okay, yeah, sorry. That is what we explained yesterday and before yesterday with the idea of thermodynamics, okay? There is the path dependence means that a process is not reversible. There's just inverting the process of applying an opposite force on opposing action. We can rejoin the initial state. Then we have another taxonomy of nodes of complexity, a bit more articulated, not argumentated, because as we will see with the argumentation of this list more perspicuous, that is given by this book, okay? Or by a paper that you can find on the drive, Measuring Complexity. That is, we have just introduced, there is a large epistemic discussion that I will not offer to you, a sort of meta-taxonomy of such elements, that we can give a sort of condition of complexity as property of a system, and products of complexity. Numerosity of elements, numerosity of interaction, disorder, non-equilibrium, feedback, this is the condition for complexity, that are the condition for complexity, and then products of complexity, non-linearity, self-organization, robustness of order, nestedness, this is sort of matryoshka, interconnected areas of the system between elements of the system. And for this idea of nestedness, we mean necessarily to model it by network theory, okay? Because we have a sort of clear presentation of the thing, how something is nested, okay? Something is clustered in something other. Robustness and function, adaptive behavior, modularity, memory. We could even begin with this lecture, but you had nothing understood what could be the pertinence of this list, or even the pertinence of the tutorial itself, okay? It's a bit, if you will, the difference between a sort of historical-oriented theoretical philosophy or theoretical approach and a very rude, even if very pertinent, approach in theory of science, okay? By theory of science, we can approach frontally and pure structurally a theory or the set of theory as complexity sciences, okay? But we don't understand how they made a revolution. For example, we don't understand, even after 3 years of physics, maybe, and history of science, how it's so radical as change of our view on the world. Okay? We don't understand why it hurts with our way of word conceiving and approaching phenomena. How it hurts with our basic feature of perceptual field orientation and hypothesis of a single framework or a single idea of spatiality. We don't understand how, for example, it collides with our idea of things. Okay? Because if we make abstraction from what we said, for example, of modern science and modern ontology, Descartes, Galileo, Kant, and so on, and we take our elemental, even implemented with informational technologies and so on, our idea of simple things. And then we explain what we will discuss in 2 minutes, okay? We are in two different worlds. They are without a possible link. So the genealogy and the critical archaeology, what stay in between, that is modern world, from point of view of science, as well as from the point of view of philosophy and modern ontology, is decisive. Okay? And it is, if you will, important even while approaching the informational revolution today. Because between our understanding, or the vague understanding of intelligence and artificial intelligence, there is a long path: evolution, deconstruction, enlargement, and so on, and so on. Okay? There is not just for complexity. Every phenomenon, techno-scientific phenomenon, as global phenomenon happening today, needs sort of archaeology of knowledge, what they say in Foucaultian terms. So let's approach the few of features that can interest us for the follows. Irreversibility. A process that is reversible can also be run backwards while still satisfying the same laws. C'est-à-dire, in order to say, I went to India, I changed the lancet of my watch, I go back to Europe, I put back the lancet of my watch, giving that I will rise, and the watch functions exactly at the same time, in the same way. Okay? That is that the clock is like, or the machine works isochronically like the pendulum. Okay? Classical dynamics, which foundation takes place between Galilei, Newton, Descartes, Newton, and then takes sort of philosophical crowning in a very small writings of Kant, Metaphysical Principle of Nature, we have mentioned yesterday, is time reversible in this sense. Every dynamically possible process running forwards is equally possible running backwards. But virtually all real processes are dissipative. The energy they degrade in quality and shed as waste during the process cannot be retrieved. That is thermodynamics. Because it is converted to heat and distributed randomly through the universe. So that cannot be run in reverse. And that has to do also with information theory, because also information theory has to do with entropy, loss of information. They also will not persist unless a supply of sufficiently high quality energy, typically in requisite material form, is available to continually renew their dissipative processes. What is the most intimus replacement of energy to continually renew their dissipative process? What is what you know from every day that renew a dissipative process? Food. That is metabolism, what they say. The food that is metabolism, okay? So in relation to what asked 2 lectures before, the negentropy is sort of action, okay? There is the constant effort of a living system to contrast the entropy and to replace the energy till a thermal death. Our metabolism is that. So it means that we are processes or made of processes that are irreversible. It's not just to say that we're going to die. That is trivial. Okay? Hence, they are inherently open systems. Only very small, brief changes may be approximately reversible, a condition especially obtaining near a dynamical equilibrium. That is not far from equilibrium, not equilibrium, near to an equilibrium. It means that it's always changing in terms of balance between equilibrium and not or far from equilibrium. So there is not, as said yesterday, order and chaos as cosmic forces ordered by the gods or ordered by a sort of demiurgic things, like some, for example, by Plato, the demiurge put the forms once more in a sort of fluctuating, chaotic chora, but there is a sort of palette of colors between chaos and order, and chaos and order are taken away from their metaphysical ontological status. It is only very small, brief changes may be approximately reversible, a condition especially obtained near a dynamical equilibrium. Many, not all, examples of complex system, and then it's for our modularity of thinking important is not all. Even if statistically are 19%, it does mean that the world is complex or nature is complex. Examples of complex dynamics, but all those concerned with living system are of this kind. Then, just in order to reply on our double pendulum, sensitivity to initial condition. What will concern tomorrow our explanation of state space and butterfly effect phenomenon. Non-linearities permit small differences in system state, and what important is for us is state. The state is not the place, okay? The state is not the place where an object lies. The state is the space, the point or the trajectory in a phase space that demands a radical revision of our idea of spatiality to be amplified into large difference in subsequent system trajectory. That is, large difference in subsequent system trajectory is the bifurcation, okay? If we heard from ecology that if we continue as business as usual, okay, to rule our industrial production, pollution, and so on, the climate bifurcates or collapses. It does mean there is no climate at all. It means that the difference in system trajectory will be larger and larger exponentially. That is, if you read in order to take a grasp on concrete things, you download the EPCC report, one of the EPCC report, and you find a bifurcation. This bifurcation indicating the urgence of a change in our policies is something that cannot be perceived because it lies in another space. The sensitivity to initial condition, for instance, a system may be poised near the threshold of changing either attractor, this is in the introduction, okay? Introduction, not to complex system, to philosophy of complex system. You can say, okay, this is philosophy of science. This is easy to do that, okay? It's philosophy of science. It does not concern me studying Foucault or studying Hegel or studying, I don't know, Deleuze, but Deleuze is just a bit, but anyway. And then changing either attractor basin, and you say, okay, I don't understand, I close the book because you don't know what an attractor is. And explain an attractor is not so hard to understand, if you will. Within the same landscape or changing landscape, and we have not to do with fine landscape of paintings, of Monet, we have to do with topological landscapes, okay? So that a small disturbance is amplified to produce a larger change. What is the butterfly effect? But we said already that the butterfly is not the small butterfly that we imagine, okay? And while systems left by disturbance inside the same attractor basin are insensitive to initial condition in respect of their ultimate destination, they may still be locally sensitive to the path taken back to the equilibrium attractor. Sensitivity to initial condition is common as amplification, and amplification is not the amplification of a sound, okay? For which we had since modern age equation and so on and so on. But under certain conditions, it takes a special form where a strange attractor is formed in which motion is said to be chaotic because it occurs at random. And then if you will have an example of the butterfly and the strange attractor at the same time, you can consider, what is, you can consider that is the butterfly we mentioned in butterfly effect. This is the butterfly. That is an attractor, a strange attractor, named Lorentz attractor. So, if you hear about butterfly effect is, okay, we can also imagine that the small butterfly caused a tornado on another continent, but it is not so fantastical as we can think by imagining a sort of catastrophical apocalypse and so on and so on. In order to understand what is a butterfly effect and why a climatologist dealing by computer formulated the butterfly effect, because in between we have to understand that, what it is and how we can apply to our conception of phenomena. And then we have to do with bifurcation, okay? Because we mentioned the first two lines of the previous article, large difference in subsequent system trajectory, what it means, bifurcation, and we will say more in detail tomorrow by the idea of phase space. A bifurcation occurs when a structural instability in a system leads to a change in its dynamical form, that is, a change in the structure of its attractor. There is no trajectory of a body like in inertial principle, encountering another body and bifurcating. There is not a bifurcation, it's a deviation. Bifurcation is that something goes in two directions. It's impossible that ontologically, empirically, a system bifurcate. You can even not imagine that a climate bifurcate, where it goes. We are on the Earth, where it goes, the climate? It remains on the Earth to go to the space. No, this is fantasy. Bifurcate, because the bifurcation is to be taken as something happening somewhere, and but this somewhere is the phase space, where we can notice bifurcation. Say, it's not real. No, it's real, because we make a taxonomy of data, we handle the data, and then we can notice the bifurcations. Please? Attractor landscape. Yeah. Explain it further. The attractor landscape is the constitution, if I'm not wrong, of the topology of the space wherein the attractor is conceived or is modeled. There is a sort of topological landscape. Then I will take you another example. That is, you have to think, that is imagination. We have to think to abstract, because we use landscape. There's something to do with the landscape. That has something to do with something ruling on the landscape. You are on a valley, fine landscape, okay? Like the curvature of space, for example, general relativity is the same thing, okay? You are on a hill, looking down the valley, and then there is another hill. You throw a ball, and this ball ideally follow the surface of the hill, go to the valley, and then by acceleration goes up to the other hill, okay? That is material. The landscape of attractor is the constitution of the space by which the system rules. It's a sort of geodetical movement, but not geodetical in the sense that we have a concrete earth. We have a ground, but this ground is made by a topological constitution. Okay? For this reason, thinking philosophically non-Euclidean geometry is important. Okay? Because it's sort of breakthrough. Okay? We have an infinity of topological spaces. And these spaces, on these phases, things, they are not things in the sense of material things, moves following the curvature of this space. Okay? You can make it just by putting a ball on your t-shirt, okay? If you take the hands very close and you move, the ball make a movement. This is follow the curvature of your t-shirt. If you enlarge the t-shirt, it moves as it moves otherwise. Because the topological, there is not a topological space in the fact, but it can explain how we can think the landscape of an attractor and how far we are from our everyday perception. Okay, how far? But not how far because we are in empty speculations that I remark every day. There is not an empty speculation, it's what we know about the real. Okay? Ladder, where its form changes continuously at some dynamical parameters, or global changes that involve more complex shift. Among the latter are phase transition, gas to liquid, liquid of solid or reverse, but this is very, very difficult to explain. For example, people is in a faculty of physics of Rome, there is an experiment during more than 100 years trying to understand how oil, there is sort of glucosic, solidifies. This is, and the Nobel Prize I mentioned, the professor of physics to La Sapienza, Giorgio Parisi, studied in a certain point the transition phase of icing water. You say, okay, it's icing water. We know how it's work. No, we don't know how it's work. We don't know how the crystals work. By icing, we know the ice, the statical dimension, the crystal dimension of the ice. We know, not fully, but anyway, the dynamic of fluids, but we don't know the in-between, what is happening, or how precisely to understand what is happening in between. Where science put the finger on the blind spot of the in-betweens of our world, of our fold, of the fold of our world. This is very delusion, but anyway. Among the latter, including critical point resolution, simultaneous transition among gas, liquid, and solid states, where changes can be discontinuous or uncomputable, and uncomputable has to do with the evolution of work on Boltzmann equation, essentially because fluctuation on every scale up to the world system are simultaneously possible. While we can study mathematically the condition under which a bifurcation occurs, beyond the simplest cases we typically have no dynamical mathematical analysis of the process of the change. Okay? Rather, the conditions of occurrence are deduced, where possible, by matching up a characterization of the antecedents and subsequent dynamical state in terms of parameter change across the bifurcation threshold. Even this independently from your orientation in philosophy. Okay? One thing is to explain to a scholar or to your child what it means. Another thing is to just understand where we are. Antecedent and subsequent dynamical states in terms of parameter changes across the bifurcation threshold. And there are phenomena happening trillions of time in a second, everywhere. There is not something isolated. Okay, we can put aside it. We can put aside the idea of bifurcation and become some idyllic idea of a very ruled or regulated world. But this is sort of plenty for ignorances, okay? Or asylum ignorantiae, where they say. Path dependence and historicity, we have already shown. I will go not so slow, but not also so too fast. Path dependence occurs like the pendulum, like thermodynamics, whenever there is a positive amplification where we already know this, for then initially nearby dynamical trajectories subsequently diverge as a function of small differences in their initial condition. So the path taken depends on precisely where the first step began. The 1% of the two pendulums is the sensibility to initial condition. Okay? What in the modern science was considered as noise. Okay? Because when we mentioned Laplace encountered such sensitivity of initial condition in his equation. It's not dumb. Okay? But say, okay, in order to fulfill my task, I would purify the equation, and then what is sensitivity to initial condition, I consider as noise. For this reason, the new complexity signs take also mottos as order from noise. Okay? Or when for example, you must identify a sound, what you make. You isolate the noise, because essential is the sound. The noise is something irrelevant. Okay? You have to focus or to catch the wave in order to isolate the sound. But in nature, the noise is not the noise, what is sort of ambivalent shape or vibrating shape of things is not so irrelevant. Is valid also from an ontological point of view. We fix us on definite things, and then we habituate, or we are used to think that everything in the world is a definite shapes. Is not the case. Okay, there are always vibrating shapes or fluctuating contours. What they say. Another subclass of path dependencies is those where, once begun, development along a certain path itself become increasingly entrenched. This applies where, for example, initial fluctuation is amplified and entrenched, especially where that entrenchment involves a bifurcation that reinforces the irreversibility of the development. Examples include a particular impurity suit of the first freezing or rolling boiling, a first genetic mutation that yields a distinctive kinadaptive advantage, or a first oil discovery or shop in a new suburb that transform a local economy. So we have many concrete examples. And the economies that you have to model sort of rise of the little shop in transforming the area of Bombay, for example, or New Delhi, have to take in consideration that there is some kind of stuffs in the world ruled by that dynamics or strange dynamics. These cases exhibit a clear sense of historical, not in sense of human history. Historical in the sense of clearly oriented and not reversible thing. Let me say, for example, for Kant, that is, for me, is not possible that we have a sort of pre-Kantian philosophy, okay? This sort of history that is once arrived at bifurcation, we cannot think as is nothing was, okay? And more and more in dynamical process. This case, or French Revolution in the West, okay? These cases exhibit a clear sense of historical possibility exploited and correlatively of others forgone, and their resulting paths are often cited to fix their initial historical condition. By contrast, for stable system in an attractor basin, there is no overall path dependence, since the same outcome occurs, captured by attractor, for all beginning point initial condition. That's an attractor for a static system, stable system is very simple. It's a segment of a line or a curve. There is not the butterfly we've seen. And the butterfly we've seen is just a symbol of the complex, because you are not a simple line depicting the butterfly of the flies of the butterfly, but many lines that not coincide with themselves. Emergence, and then maybe we will stop. No, modularity, because it's important also pedagogically. When the outcome of dynamical interaction among system components is surprising or unexpected, and we are here in the one of the huge problems for ontology and metaphysics nowadays. Okay? But let's take, as said, firstly epistemologically and then ontologically. When the outcome of dynamical interaction among system components is surprising or unexpected or too complex to readily understand, scientists are apt to talk about emergent patterns. There is a distinction, not normative distinction, just pragmatical distinction, between scientists and ontologists, will they say, or metaphysical ontologists, because where scientists or philosophers like me, but like others near to science, speak ontologically about emergence only in terms of weak emergence, there is an impossibility to determine, ontology and metaphysics today speak either about strong reduction, negation of emergence, or about or of strong emergence, what we will say. So these scientists are up to talk about emergent patterns, okay, but in a weak ontological meaning, a weak ontological sense. However, this is a vague, shifting, and subjective approach. In colloquial usage, emerge often means no more than becomes perceptible, limiting emergence to the appearance of a phenomenon that could not have been predicted from knowing only the pairwise dynamical interaction of components sharpens it somewhat. But this still ties the definition of what is a physical property or intrinsic property, or ontologically speaking, natural kind, to a non-dynamical criterion. Indeed, since prediction is often limited, many behaviors will count as emergent thus on these grounds. For example, the jump or the phenomena on the in quantum theory as not emergence. So, phenomena of first quantum theory and not emergence. Phenomena in the, for example, cosmological theory are emergence, but it is two different kinds. We have to differentiate. Not because we can understand that's emergent. Okay? There's other necessary condition in order to call something emergent, something as a novelty, even from an epistemic point of view. Indeed, since prediction is often limited, many behaviors will count as emergent just on this ground, but it is instead the alternative option of pursuing a dynamical criterion. A clear wide criterion will be to identify emergence with bifurcation generally. In a clear narrower one would to be identify it with just self-organization. But that is not the case. If you take this into ontological account, it is more complicated. In each case, a new dynamical form does come into being or into manifestation. Already into being is a very, very strong ontological commitment. Other criteria are possible, see criterion 2 above, but these are the clearest, simplest, dynamical grounded ones. And if the epistemic and semantic criteria are removed from the section 2 list, then plausibly the remaining criteria all work of one of those two dynamical criteria. Argues for the wider usage on the ground that emergence is concerned with new dynamical character as outcome, not the process producing that results. There is a sort of between condition and results of complexity if we take the second list of taxonomy that we take in account. A system contains modularity that has to do with holonomic and non-holonomic constraints, as well as a sort of more difficult to understand mereology, that is relation of whole and parts, as we know from the classical theory of objects. A system contains a module if and only if, to a sufficiently good approximation, for example, to capture essential system functionality, its dynamics can be expressed as an interactive product, the dynamical product of its intramodular dynamics and its intermodular dynamics. You know, that what's important is intramodular and intermodular. But the problem is in which space or in which form we can determine this inter and this intra. still with a form of spatiality. For this reason, it's useful to think in terms of networks. Not just for this reason, but for many other reasons. But you know, you have a sort of clear tool to represent things otherwise where dynamics can be represented. This kind of modularity can be distinguished, spatial or horizontal, level or vertical, and process modularity, labeled respectively S, L, and P modularity. And I let you explore that because we will, sorry.
From the following section, are you talking about distributed and decentralized systems to understand them?
From the next session,
Upper line, that is capture the essential system functionality. Second line.
yeah,
Yes, for this, I'm asking, are you talking about distributed and decentralized systems?
in which sense? Distributed and
Decentralized systems are two kinds of systems through which we can understand or map complexity. In network and information science, we use these systems as well.
I don't know to answer. You can clarify things after, okay? Even coming here. So let's come back to emergence, because emergence is not emergence of the whole, of a new whole, is even emergence in inter or intramodularity. Emergence occurs in terms of function, simple structure, causally underlying function of more complex structure. Development, that means the modularity even of the concept of emergence. For example, the vibration of a muscle is an emergence. It's not a deterministic thing, not fully complex or fuzzy, but anyway, is a development of single initial cell growing to a complex interlocking set of 10, 30 cells, and evolution, a universe region containing no complex systems, evolving to one containing billions of them, each occurring with a different time scale, each occurring with their different time scales. So we are punctually, so we'll skip these three because we will just talk about that. I will reproduce the slide once we have talk about biological system. Okay? So we can take a break and come in 15. Okay. We are here in order to ask questions, clarify point by point. We have 40 minutes, 50 minutes even, or even more, in order to unfold what you have. And you can also come here to ask the question in order to let our colleagues, our fellow, not to turn around the room. So, are there questions? Yes.
I'll ask from a Deleuzean perspective. So, when Deleuze gives his...
Come here. Oh, no, okay.
So, Deleuze gives his differential ontology and he takes it from Leibniz's differential calculus.
Didn't understand. What?
It's from a delusion perspective, right? So a lot of stuff that we did today is very delusion, as you rightly pointed out earlier. And my question would be that when Deleuze gives a conception of difference in itself, right? When he's talking about differential ontology and he's talking about movement there. So every difference is a movement and every repetition is a movement, but it's a difference in itself as opposed to representational difference. So how do you account for an epistemology of such system, differential ontology, and how far does differential calculus go in
Differential calculus.
calculus go in mapping the movement? Because that cannot be, according to Bergson also, duration is just intuition. You can intuit duration, but you can never represent it. So my question would be that.
So, I have just to confess that while very, very appreciating Gilles Deleuze, in my view, one of the most profound thinkers on the contrary of opinion of analytical philosophy of our time over the 20th century, and having worked on his historical works and its metaphilosophical book, Qu'est-ce que c'est la philosophie? I have many problems in order to catch up what is différence and répétition. But let me to say that is open, critical, and very, very lucid approach to our time can go in the same direction and outlines essential features that are not catched, for example, from ontologists and metaphysicians in an analytical way, and even deeper. So you say it's very delusion. It could be very delusion if I take Deleuze at the ground of my, it's not the ground of my philosophy, because it's just one of the field of position of my philosophy. But you're right that the idea that the movement does not repeat the unit and open new immanence plan, let's say that, immanence plan, is a very, very fruitful idea. So, and I worked on immanence plan, but I think that one of lacks of Deleuze's perspective is hidden systematicity or refusal to bring all of it in a clear, formalized way. It's not the task of Deleuze. I hate people that criticize other philosophy by mentioning what they had to do, instead of mentioning what we have to do. So take Deleuze for what it is. Deleuze is also very, very attentive to every kind of knowledge moving around Paris at this time, and there is very, very good mathematics. It's not excluded that it was inspired also by some suggestion coming from the École Normale, all the very good mathematics and philosophy of mathematics made at the École Normale. But I have some difficulty with that. I would have problems to bring what Deleuze say to a clearer, systematic view. Okay? Then, so for this, I come from phenomenology and other things. But anyway, it's true that from the Leibnizian studies till Mille Plateau, Deleuze catch a new shape of what, not the word is, because it would be too ambitious, or even for Deleuze, what the movement of our thinking can be after metaphysics, or after that form of metaphysics. So he was a huge philosopher, and you find deep intuition and very, very, historically speaking, is a giant. When you can also watch on YouTube the lesson of Deleuze on Leibniz. It's wonderful. Then I will be most oriented to take it structurally. So the problem is that ontologically, but not also ontologically speaking, the relation or opposition between identity and difference, or between unique and uniqueness and otherness, is not so Manichaean as those thinkers could presume. You know? For example, let's take one thing on which I worked longly. This is what is philosophy, okay? And the idea of immanence plans. I agree, but how can I give me clear insights about such plan? It's very unstructured by Deleuze and Guattari. Also, the idea of fostering or sort of other development of knowledge as in the form as a tree, you know, I agree completely with that, but we need, in order to make a step forward, to have clear forms that come from my Kantianism, from my Husserlianism, or from my studies on mathematics. That is formalization, and then we have mathematical structure that enable us to do that. For example, what we will say on network modeling is very, very close to the idea of Deleuze. That is something as a theory is so ramificated, but not in the sense of a tree with a full body and then with branches, but sort of another vegetal structure. Ramificating is not so ramificating, is bifurcating, intertwining structure. I fully agree, but I prefer to take inspiration from Deleuze, because it's not necessary that when a philosopher works, I have to take all the package from every philosopher or from one philosopher. Take many inspiration. I read Deleuze. By reading Deleuze better as I can read, for example, Derrida or Levinas, with one I have strong difficulty to concentrate myself. With Deleuze, you can follow. There is some even a political commitment that helps me to follow and to sympathize with Deleuze. But I prefer to work with some more structural stuff, let's say. But you're right, and there is even the genius of Deleuze. Our time can no longer assume the form of the old time, of the time of modern metaphysics, the time of distinctiveness, of distinctedness of the thing, distinctedness or the fully distinctedness of conceptual structure, and so on and so on, and even not assume that such dynamics are linear, arborescent in the sense of vertical arborescent, and so on and so on. Then taking stance on this common sharing of the diagnosis of our time, what is the same, if you will, that is shared with large parts of the archaeology of knowledge of Foucault, then I would like nuance this radical antithesis between rationalism as domination, as postmodern. They are not postmodern. I don't understand what postmodern is still. But what anti-rationalist libertarian is, by saying that we have now tools in order to take that stance with more strong tools. Okay? But there is more to think, even in order to let be inspired from the work of Deleuze and Deleuze-Guattari after. Because he thinks the real and the world really deeply. And I've been a post-analytical continental philosopher, God will. So I don't recognize the dichotomy, and I don't will recognize the dichotomy, but many people should go on the other side, on both sides, in order to search something that can implement their thinking. And this opposition between philosophy and formalism is not mine. It's not mine. As, for example, the radical antipathy of Foucault for every form of transcendental subject. While having written, I don't know how many times, and deeply appreciated the trilogy ending with Archéologie du Savoir by Foucault, I find that even in this perspective, other forms of transcendentalism are not so dangerous, are not so symptom of the coming back of the old tyrannic, rationalistic idea of subjectivity, you know? That's maybe my phenomenological heritage. Yes?
Just building on what she was asking and your response, you were talking about symmetry breaking and linearity. Symmetry breaking and linearity, and I would like to understand exactly where are there any continuities or discontinuities which lie between the symmetry breaking as opposed to fractals with relations to the arborescence schema or the rhizomatic schema, right? Are there any continuities? Because the nonlinear systems of chaos theory sounds vaguely or oddly rhizomatic to me. Simultaneously, so does network theory. The network theory that you were talking about, does that have anything to do with...
It's rhizomatic. There is no directed center, so it's rhizomatic.
Yeah. Is it Latourian with the actor network theory of that sort? And is there any continuities and discontinuities with what you call necessary reductionism, or that complexity is in relation to complex systems? Is there any connection between what Ulrich von Huxell calls the Umwelt, or what Uxel? Umwelt.
Okay.
Umwelt, or what Peter Sloterdijk talks about as spheres, right? Like the micro to the macro, and the bubbles that the spheres of knowledge or complexity that they talk about.
Without doubt. And I will methodologically put some distinctions. And it will explain to you, if you will, also the way I take. I'm not so sympathetic with the idea of sphere, because it belongs even to sort of idea of perfect geometry. But anyway, let's take the rhizomatic, the rhizome. Of course, there are deep similarities. And by reading, by unfolding the idea of rhizomatic, I did so, we can also find new insight in approaching network theory. But the problem I have is not arrive to grasp what is at the end this shape of rhizomatic. Instead of it, when I talk graph theory, I can grasp, I can handle with something, with formula, with structure, with clear statements, and so on and so on. You say Deleuze should not, or was not forced to do it. You're right. But while considering philosophy as a work primarily, not taking stance for authors, I will say I let inspire myself. I share the idea of rhizomatism, or the general rhizomatism of life, of theories, of many kinds of things, but I prefer to work otherwise with concrete notations and positive signs. Just that. There is not a sort of discard or accept, because it's very risky today in the greed in philosophy that has been transformed in a sort of huge mall or supermarket to have to choose between product. There is not product, there is Denkwege, this way of thinking. And we can also follow till a certain point the way of thinking and then take our own way of thinking, or to regain our old way of thinking, nourished by such inspiration. You know what? Rhizomatic, or the rhizomatism, is a very clear and, in my view, very insightful idea of Deleuze. Maybe that of plan of immanence are the most insightful idea of Deleuze and Guattari. The problem is, when I want to follow how something rhizomatic works, I can no longer stay in the rhizomatic of Deleuze, because I have no tools for doing it. Just that. You know? But for sure, if I have to choose between moving, opening to the world, politically committed, protesting philosophy, very informed on the history of philosophy, like the philosophy of Gilles Deleuze, and the ontology and metaphysics by which, through two statements, you can claim that by metaphysical necessity life is strong emergent. I choose Deleuze. But the problem is philosophy is work before choosing what other we like or we dislike. You know, it's a matter of the thing in itself. Die Sache selbst. What helps me, die Sache selbst, to decipher. For example, now we're working about the sort of idea of rhizomatic of experience by Husserl. There is, you know, the sort of Neumann horizon relationship with Heide and so on and so on. Of course, it's more similar, more close to this idea of rhizomatic than to the idea of strong conceptualism referring to thing or to Bedeutung in the Fregean sense. But we work it with my assistant with network theory. You are more, you know, you are more tools. You know when it cracks, when it works, and so on and so on. Maybe it's my scientific education, but the need to handle with a toolbox, in order to use the expression of Foucault, that can help me to reach something that I will to reach. It's more pragmatism, because now, since the beginning, the ideological, the analytical continental divide has been established as something ideological, either to belong to the old world, communist, strawberries, protesting, or to you are the cool analytic philosopher coming from the United States. So I belong to the old world, clearly. But I will not to choose in world war to belong while we live in a new world. And even for philosophy, in my view, is the same. So I refuse to accept the dichotomy orienting my choice. So I work on philosophy, theoretical philosophy, more as an analytical philosopher. I'm not so fanatical to claim that Deleuze is no philosophy at all, like many people claim in a large part of the world, or like even Heidegger is no philosophy, or even like Husserl is no philosophy. So until point we have to erase philosophers in order to make good philosophy. So you can also, so I work because even the discursive orders, I work more deeply on the discursive orders, not for what concern our topic here, but for what concerns meta theory of this topic that I've developed and I'm still developing, I more closely worked on the idea of discursive order and this huge phenomenology of discursive order made by Foucault. But we can also distantiate us from Foucault. We have not forced to take all Foucault to take all Foucault in account when we do a philosophy that go beyond this divide or not. So rhizomatism, a rhizomatic form of discursive order is, of course, what fit at most with the life of knowledge. That is for sure. Then generalize that say that just rhizomatic or rhizomatism is the form of everything, I would say not. But even Deleuze had say not. It was very, very strong in his approaches. For example, bifurcation has to do with rhizomes, but has to do even with plants, so or with trees. So bifurcation, just don't take the bifurcation as we take in a very, very clear and identifiable sense, without analogies, without equivocity. Work on it and then maybe associate it to a general idea coming from other readings, coming from other others, and so on and so on. In my view, if you take bifurcation, if you will understand what bifurcation is, you have to take the thing in itself, contextualize in the scientific context, handle the language, and then eventually copy or superpose or overlap with other more fluid way of thinking.
So I think you're also like more into like maybe subsuming difference under the identity in Deleuze parlance, right? So what you're doing with bifurcation, so it's a difference, right? It's a rhizomatic difference. But with your project, you're trying to again subsume it within the identity. So you're studying it in relation to the linear progression and how this happened. But what Deleuze is doing is just coming with a novel conception of difference in itself. So just let it, because he does not want it to subsume it within an order. Yeah.
What I'm working to is not at this level, but at the level of eidetic structures. Okay, this is concretion of sense, of meaning. Working something that does not belong to discourse, that go in the direction of a rhizomatics, because in the thing in itself, our ideas are not like trees, it's sort of like bifurcating, but the rhizomatic evolution of a concept of or a concretion of sense in 2, 3, 4 different ways and then intertwining is not like this bifurcation. There is two another space, or there are two another space model in order to think that, with two different strengths of affirmation. If people like a climatologist say that something bifurcate, it can indicate what is the construction of the space, what is the taxonomy of the elements, what is the captors that capturing the empirical element, and so on and so on. When I work on rhizomatism of pneumatic structures, already the space is a bit uncertain. I associate to the space something that cannot be captured because, as we said, is not something belonging to a natürliche Einstellung, and then we have to create this space of phenomenological consideration. It's two different matter of things, you know. Then we unify in a general idea and so on and so on. But being able to differentiate and not to bring everything in a triumphal global analogy is for rational work useful, without being dominant totalitarist, you know, that's something very, very methodic. Like when you write a symphony, like when you build a spaceship, when you make a painting and so on and so on. You have a certain, the gesture by which you accomplish your work comes from a technique that is very lucid. Even at the ground, there is a sort of innovative claim. Yes.
So I'm still quite struggling to grasp most of what is going on here. The physics and mathematics seem to be currently lost on me. But we were just now speaking of postmodernism and a sort of So my question that also stems from the way you have titled the tutorial. It's the way that you have titled today's tutorial. It has towards the direction of policy making. So while I understand COP26 and Paris Agreement, I wanted to ask what sort of cultural implications it has, specifically in the sense of a globalized world. Whereas in Germany specifically and Europe in general, we speak of integration and assimilation towards a Homogenisierungsdruck, a shove or a push towards homogenization. So what kind of direction would our understanding of complex world take in a cultural sphere when it comes to policy making? If it has any cultural implications, one, and if it does, then what sort of?
So then we implicitly we come back often to political stance taken by a theory and even by Deleuze and Foucault and so on and so on. I reserve the policy-making implication of complexity theory for the last lecture, but let's anticipate just a bit. So, I will say it straight, and then we can articulate. Taking cultures and societies as blocks to be homogenized is, in the best case, delirium, and in the worst case, I don't know what it could be, and we know even from far, and we resist of it, and our elder resist strongly of it, what it gives. So, but it's very, very stupid also. So the problem is that you can't do it when you are strong, dominating enough. No, it's stupid because it's stupid. It's inhuman, and it does not conceive even the structure of humanity circulating, hybridating, variating, and so on and so on. So it's very, in my view, is even strategically stupid. So that we have to distinguish between strategy and political. I will not talk about political orientation. In question is not my political orientation. Let's take the two stands. The thing in itself, as we can analyze, and the policy making we can do. So, the thing in itself, as shown by this American, very clear American things, a social group or a hyper-complex group as something like a nation or a country, okay, is something of a huge complexity you cannot homogenize, okay, while maintaining the life itself of the society. So this idea, already sociologically speaking, even from the point of view of liberalism, is delirant. So no more to say. Policy making, speaking from the point of policy making, the problem is if we talk utilitaristic, it is useful or not. So even considering, because I'm European and then I am Italian, French, German, and so on, even considering the difference between many regions of the same country, many culture of the same country. Of, in a unified Europe, the huge difference between 30 kilometers on the one side and the other side of the Rhine River. This idea, this policy of homogenization is false, but it's also very dangerous from the point of view of growth. Growth.
Okay.
Okay? So one thing is to say we make a fully open country with deregulated immigration and so on, that will pose other problems. But homogenization is, even from point of view of strategy, from point of view of ideas, from the point of view of resilience, from the point of view of elasticity, of social tissues, and so on, something out of the world. And today, in a global world, more than ever. So there is no question about it, in my view. Then people, I presume, people speak about homogenization in order to differentiate socially the thing. If you are inside, you're privileged, and the pariah, or the pariah of the world, will produce the goods in order to let us live as we will. But there is many hidden plans that are not mentioned in this idea of homogenization, of purity. For example, there are people that don't know of what they speak, of what they speak of about. The people in Italy, they talk about the purity of Italian type, not race, but type. So if you consider just the history, Italy was everything but the purity of a type, because the richness of purity, the richness of Italian culture, come from going through the land of dozens of impulsion coming from the north, from the south, from the east, from the west, from everywhere. And that gives the richness, inventivity, and creativity of the country. So people today speak, but today people, and we reach the rejection of a complex world. The system, the psychotic mechanism of rejection, of falling in old identities, claim that there is something old, because you can't get globalization of goods, of production, and at the same time homogenization of society. That is not working so well, okay? Like you say, you will fresh water, but you close the tube. This is not working, okay? Maybe this narrativity comes from the rejection and the fear of the opening of a complex world. Come just like that, and in consideration of the fact that there are every sooner elections, the people would realize with gastropopulism that there are still one identity, there was still one thing, they are not a folk, they are not a people, they are no longer a nation, for example. There is something, but something stable, okay? And objectively and strategically is delirant, but we have to ask what stays on the background of such fakes, like in America, okay? One colleague said to me that America was built from the Jews, from the Irish, and from the Italian. That's maybe the case, but anyway, it not depends. So the purity of what? It happens, and from the black people as slaves, that happens 2 centuries ago. the idea of homogenization of a society, and then from this melting pot come even the creativity, come even many things. So this idea of homogenization or even integration, or the forced integration, it seems to me sociologically ungrounded, strategically very false, but grounded on a common feeling. Not by chance, the populisms and nationalism, they are fake now, arise in every country of the world. Because every identity facing this idea of standing, complex, changing, must grab something fixed, even if it's a fake, in order to be I don't know, anesthetized against the fear or something like that. So there is a reason, not a good reason, not a scientific reason, not a strategic reason, but there is sort of psychological collective reason in such discourse. Because even by minimally applying the 2-3 examples about populations that we watch in short tutorials, we can become aware of the fact that such discourses have no sociological, geopolitical, ethnographical, I don't know what, ground. But they still become stronger and stronger. Because it depends from the fact that we face an era where all the patterns collapsed. And then the people try to take back old patterns in order to interpret it and so on, like the earth flatters. If you will, is exactly the same thing, okay? A simple, popular, or the populist version of a being in the world that can be sold even in 2 minutes objection in every talk show, useful at the moment, but very dangerous on the middle and long term.
So I had 2 questions.
Yeah.
The first is, like, because you, in the first 2 lectures, you had described how there is a kind of idea that the universe or the world can be mathematicized with Galileo and all. But there is also this problem after, I think, because of this failure of classical mechanics, because classical mechanics is also based on a kind of, what you today also said, a kind of removal of noise and to see the specific part. So what I understand from today's lecture and the kind of new developments in physics or mathematics, it's to say that this noise also can be mathematicized, firstly, and secondly, that the thing which this clear distinction that we made between the simple and the noise, this simple, there is noise even inside
clear
this.
And the noise.
Yes, there's noise even in this clear thing, which has to be then kind of formalized. So, in that sense, my question is that, in a way, what we are considering of is as a complex world, or the relations what we saw in the video also as elements of a complex world. Aren't these elements also a world in itself? Like aren't these elements also kind of complex in that way? Like, when we are considering these as elements, aren't we kind of removing the complexity and making these elements to be considered as simple? Like, suppose if we consider this idea of the flock of birds, which you said yesterday, isn't the bird, in one sense, isn't even a bird a flock in one way, in the sense of complexity?
Okay, that's the microcosm mirror itself.
Yeah, basically basically even the one which you consider as one element, even that is also multiple in one sense. Okay. So how do we deal with this?
I let you. I come to the first question. Answer to the first question. Of course, mathematics now give chance or they enable us to consider or to mathematize what before must be put aside as noise. What comes before? Either the awareness that the noise is not so noise but is central, and then or the mathematics that go from, we cannot decide, in the sense that what causes the other. There are so complex processes even in science that we cannot say. It is not unuseful to say if mathematics give rise to consider the noise or the awareness of the fact that the noise is not so secondary give rise to the mathematics. There are genealogy, they are not so fruitful per se. So we can take in account the noise. We can take in account with a wide spectrum of scientific tools what at the time was just relegated at noise. Okay? For the second question, let's take bird flocks and bird. Bird is a complex system. Okay? The tissues of metabolism of birds, its concept system, you go deeper and deeper, but at a certain point you can find something that is not complex. So this full holism of the mirroring between the microcosm and the microcosm is something metaphysical. And I'm not sure, and this is my questioning since 20 years, if the greatest revolution of complex system, complexity of the world, is to free us from metaphysical hypostasis. So do we need to establish this perfect mirroring between microcosm and microcosm? And then the problem is that there is also the mesocosm and then mesocosms. So when we will handle with this notion, we are all in trouble, always in trouble. In my view, we can reach another kind of globality, a globality of vision and approach to the world without establishing this metaphysical correspondence. If we let converge, on one side, these issues, and on the other side, the long discourse about the history of metaphysics and the history of ontology, on the end of metaphysics, okay? Maybe we can reach this elementary awareness that speculative thinking or global view are not necessarily grounded on such übersinnlichen, not oversensible infrastructures. That can belong to Cusanus, that can belong to Leibniz, but it's not sure that works with this novelty of our civilization, and it's not sure that we need of such perfect correspondence between microcosm and microcosm in order to do speculative thing, or to think speculative.
No, I'm not actually saying about the kind of correspondence between the macrocosm, but I'm saying that suppose a flock consists of many multiple birds or basically different elements, but the bird is also consisting of different elements. Like I'm not saying there is a correspondence between
consisting of
different elements in a way. I'm not saying of a kind of correspondence between the two, but I am saying that like while we are constructing a complex system, we are considering it a complex system. Should we not also consider the complexity of each element also?
It depends on which scale. For example, for a bird flocks, you have not to consider the physiology of the bird. Maybe you have to consider just the system of response of issues to nearby birds in order to orientate without a center. Maybe when you consider the complexity of becoming ice of water, okay, you have not to consider the structure of the atom, because the complexification of phenomenon lies on a scale that do not belong to elementary ground of subatomic interaction that remain steady or remain the same without complexification. You know, for example, even in the macro scale, if you consider the building flux, you cannot even take in account the complexity of atmosphere. That is the sense of locality of complexity. You have not to spread the observed complexity to the model in order to catch that kind of complexity to the micro and to the micro to the macro scale. You have to have a sort of focus on the scale and the typicity of the phenomenon.
Yes. And the second question I had.
That was just the first. Please.
Yeah, the second. Yeah, this is the first. The second question I had is that how do we understand, like taking into view the idea of complex system, how do we understand the ideas of necessity and contingency in the view of a complex system? Like what may be, because if
there is still an idea of necessity in complex system. Maybe structural necessary condition, but I would differentiate the model predicates in many contexts. There is as we have no one meaning of necessity, reality, and possibility, and maybe for this differentiation, let's take the model concept just a bit aside. This is what is necessary in a complex system. Structure, constitution, laws, because there is something remaining the same. Maybe that is necessary in order to accomplish or to let emerge a complex behavior. There is a sort of necessary condition. But one thing is necessary condition, one thing is necessity. You know? Be local in order to become global. Necessity as general metaphysical or general model metaphysical predicates in this context is not so useful. For this reason, the modal metaphysics of possible words in analytic philosophy take care to handle with complexity and speak always about individuals. They know what they do. Because here you have to differentiate necessary condition, what is necessary for what is conditioned for what, and so on and so on. There's no general necessity or not general possibility.
I was just wondering if you could elaborate. I'm still a little unclear on what you mean by finite deterministic chaos and what you say an attractor landscape. You said it is topological and you gave the example of but is there a more real world example that you could give to help me like negotiate this idea?
This is the topic of tomorrow. Precisely.
Oh, it's the topic of tomorrow.
It's the topic of tomorrow.
Okay, and finite, that is also tomorrow. Finite deterministic.
Finite deterministic predictions. Not
Okay.
finite deterministic chaos.
Chaos.
Where do you find it? Finite deterministic unpredictability.
Unpredictability.
It's not finite deterministic chaos.
Okay.
Yeah, this is with. I just defined that, and then finite deterministic unpredictability. It means very technically that with finite methods, that is without presupposing an infinity as element or your proof, you cannot determine or predict deterministically.
So in a limited set, like a given set, or
Even huge set of fall is always based on a limited number of cases of limited section of time and so on and so on. You cannot postulate that at the infinite you can approximate the behavior till exactitude.
so even the universe or the cosmology becomes a finite set.
No, we are far from it. We are not in cosmology. Maybe cosmology can, by adopting a complex point of view, approach a finite deterministic unpredictability, but the finite is linked to finitistic methods of proof. So you have even to presuppose that your predictability goes on a spectrum of time, on a spectrum of repetition or reiteration, and so on and so on. And for the topology of the model is precisely what we will talk about tomorrow.
Thank you.
I don't know whether you'll discuss it or not in this program, but I was interested in the, political ramification of this. Like when we see that there's no, modes of thinking, political thinking, or the way we think about politics will also change. For example, let's talk about, a complexity in what you were saying in answer to his question of recognition, for example. If a community of people,
No, this is the problem is every committed man or intellectual huge today to talk about politics. So the mind inflames itself, but the risk is that we run to easy conclusions. So there is an introduction to complexity today, or sort of education to things otherwise the world. I will not touch political conclusion. Why I can give you privately, we can lead a discourse on it, because it's a very psychological thing. If something is urgent, the lucidity of mind will be switched. So, complex geopolitics, geopolitical situations are complex. We can eventually make another course, not in India and so on, it's not a self-invitation, but anyway, it's possible to make complex geopolitics, or to educate, I will not the best person, but anyway, to handle political problems today, complex as they are. But you have to go carefully, That's what differentiates science or the knowledge and not knowledge. There is not a political debate. Now we learn to think complex, to think otherwise by true complexity manifesting itself everywhere in the world, and mostly in geopolitical issues. But if you run to the conclusion, we don't assimilate the tools that enable us this new view. As you will play a sort of, NBA final without know the fundamentals of basketball. You cannot do it.
No, for example, in philosophy, especially in terms of, for example, there's a book on Spinoza. I think I'm not remembering the name of the professor. So about not Spinoza's per se, but a secondary scholar. So he talks about how political moral psychology works. I think it's I forgot his name. Moral psychology. So especially in analytic philosophy per se, moral psychology has come up.
The Wild Anomaly.
No, not the primary one. I think Tractatus Theologico-Politicus is the primary work on which the scholar has written a book. So he talks about like the moral and psychological aspect of politics. So like trying to taking an interdisciplinary approach or taking a more of a complex approach to politics itself, or how an agent comes into picture. And all those, like he's integrating all those theories together. So that's why I was asking that question.
Yeah, but it's too far.
Yeah.
It's not reachable in this context. Maybe if I stay 1 year or 2 years. Anyway, so science, knowledge is passions, is method, is even if existential global political problem huge. For this reason, people build universities, because you let scholar protected from these urgence and let discover, And if you conceive the philosophy as a strong form of knowledge, you cannot expect from every philosophical approach of every point of the horizon of philosophy to converge to another point as nothing were.
Yeah, I was just suggesting as a point of orientation to look into problems of, like for example, law, or even like how to consider what an agent is, like in terms of free will and agency, and applying those problems to it.
There's a huge problem. You have to thematize the free will. You have to thematize how the free will is implemented in a complex society, how it's limited by which is not something that we can even thematize definitely in one course.
Yeah. Too much expectations.
Any more questions?
No. Okay.
And Nancy.
It's 6:20. This is.
No, it's 5:15, 5:20. Yeah, bro. Nancy, do you have 5 minutes after this?
Yeah.
Oh, sorry. I forgot.